Okay, so we're going to be doing chapter 21, Systems of Equations and Inequalities. So before I start this video, just remember, look at the description over time for anything that I add, and I would suggest that you go and watch the SAT systems video actually before watching this one to get an idea of how to do these types of problems. And let's get started. So for number one, it says an opera house sells adult tickets for $10 each and child's tickets for $5 each. If a family purchased a total of 12 tickets for a total price of $85, how many child tickets did they buy? So the adult tickets are $10 each. So let's call the number of adult tickets A and the number of child tickets C. So if we say $10 is what each of the adult tickets cost, the cost for all the adult tickets would be 10A. And then if we do the same thing, but with the $5 for each of the children's tickets, we're going to get how much it would be for the children's tickets. And it said that in total, the price was $85. Now remember, A and C are the number of adult and child tickets. So if we add them up, we should get the total number of tickets, which is 12. So now we have a systems of equations that we can use to solve for C, because that's what we're interested in, the number of child tickets. So what I'm going to do is I'm going to subtract C from each side of this equation, and I'm going to get that A is equal to 12 minus C. So now I know A is the same thing as 12 minus C, so instead of writing A here, I can write 12 minus C. So that's what I'm going to do. I'm going to say 10 times 12 minus C plus 5C equals 85. Then I'm going to distribute the 10 to each term in parentheses, and that's going to give me 120 minus 10C plus 5C is equal to 85. Now I'm going to combine my like terms of minus 10C and plus 5C. That's going to give me negative 5C. So now I have 120 minus 5C is equal to 85. And then I just need to subtract 120 from each side. So when I subtract 120 from each side, I'm going to get that negative 5C is equal to negative 35. And then if I divide by negative 5 on each side, I'm going to get that C is equal to 7. So the number of children's tickets is 7, so it should be A. So let's keep going to number 2. It says, at a startup celebration for developers and designers only, there are 30 more developers than designers. Out of the 80 employees at the celebration, 20% have remote jobs. Which of the following is closest to the maximum possible percent of the designers at the party who have remote jobs? Okay, so let's call X the developers, and we'll say Y is the designers. So let's see, it said that there are 30 more developers than designers, so we could say that X, the number of developers, is equal to the number of designers, Y, plus 30, because there's 30 more of them, right? And then they said out of the 80 employees at the celebration, 20% have remote jobs, and there's 80 employees at the celebration. So that means that X plus Y, the developers plus the designers, have to equal 80 for the 80 total employees there. So now we have a systems of equations, that we can use to solve for what Y would be. So let's do that. So let's see what would be easiest to work with. Well, we already have this set up as X is equal to Y plus 30, so let's just plug that in for X over here. So instead of saying Y plus 30, for X over here, instead of saying X over here, I'm going to put Y plus 30. So Y plus 30 plus Y is equal to 80. And then I'm going to say, okay, and now I'm going to combine my like terms of plus Y and Y over here. So then I'm going to get 2Y plus 30 is equal to 80. Now I'm going to subtract 30 from each side, and that's going to give me 2Y is equal to 50. Now I'm going to divide by 2 on each side, and that's going to give me that Y is equal to 25. So remember, Y is the number of designers at this party, and we want to know which of the following is the closest to the maximum possible percent of designers at the party who have remote jobs. So if there's 25 designers at the party, the max could be that all the people who have remote jobs are designers. So we could say that we're going to do 20% of the 80 employees have the remote jobs. And so 20% of, and I'm saying 0.20 because 20% as a decimal is 0.20. You just move it to the left by 2. So 20% of 80 is going to equal 16. So that's the maximum number of people that could be remote, or employees that could be remote. And that means that 16 out of the 25 would be the maximum possible that could be remote out of the designers. So 16 out of 25. So we could say 16 out of 25, and if we want to turn that fraction into a percent, we just multiply by 100. So then we have 64%. So it would be, which is of closest. So then it would be J. It's not exactly that, but it said closest. So let's keep going. So for number 3, it says, what is the x-coordinate of the point of intersection for the two linear equations shown? So remember, when they intersect, that means we can set the equations equal to each other, because they should have the same x and y coordinate, because they should be at the same xy point. So I'm going to set these two equal to each other. So I'm going to say negative 4x plus 15 is equal to 6x minus 10. And then, let's see, I'm going to add 4x to each side. So then I'm going to get 15 is equal to 10x minus 10. Then I'm going to add 10 to each side, and that's going to give me 25 is equal to 10x. Then I'm going to divide by 10 on each side to get x by itself. And I'm going to say that x is equal to 25 over 10, which is basically 25 tenths. And another way that we could say that in decimal format, like using our place value, would be C, 2.5, because it ends in the tenths place right here. So that's 25 tenths. So let's go to the next one. So we have all of this, and they want to know what x minus y is equal to. So we have to figure out what x minus y is. So let's set up our system of equations on top of each other, like this, and then it's x minus 2y is equal to 11. Okay, well, right away, I can see, this is why I like stacking them up, because you can tell whether, like, substitution or elimination will be better. So, like, here, when I stack them up, I see, oh, if I just subtract these, I can do elimination, because minus and minus is plus, so then it's negative 2y plus 2y, which cancels out. So, we're going to subtract all of this to do the elimination method. So, negative 7x minus x is going to be negative 8x. And then we're going to say negative 2y minus a minus is plus, so plus 2y, that cancels out. And then we have on the other side of the equal sign that, whoops, let me just fix that. That's supposed to be an x. Negative 13 minus 11 is going to be negative 24. So now I'm going to divide each side by negative 8, and a negative divided by a negative is a positive, so this is going to be positive 3. X is equal to positive 3. Now remember, they want to know what x minus y is. So now that I know what my x is, I can plug it into, I'm going to just pick this equation, but you could pick the other one if you want. It doesn't matter. So I'm going to pick this equation, and I'm going to put in what I know x is, 3, and I'm going to solve for what y is. So then I would get negative 2y is equal to, I'm going to subtract 3 from each side. So then when I subtract 3 from the left, it cancels out, and when I subtract 3 from the right, I get 8. So then I'm going to divide by negative 2 on each side, and then it's going to be negative 4 for y. Now I know what x and y are, so I can do x minus y. So x, which is 3, minus y, which is negative 4. Minus a minus is a plus, so this is going to be 7. J. Okay, so let's go to the next one. Number 5 says that in the system of equations above, a and b are constants. If the system has infinitely many solutions, what is the value of a over b? So we want to know value of a over b right over here. So let's see, let me just take a second to look at it. So if it says that there are infinitely many solutions, okay. So infinitely many solutions for like a systems of equations would be like the same exact line for each of them, because the solutions for systems is like the where they intersect, where the two lines intersect. So like if you have infinitely many solutions, you have infinitely many points of intersection because they're right on top of each other. They're the same line. So let's see if we can make these equations the same, basically. So I see that if I multiply this by 2 on the bottom, I'm going to get it to look more like the top equation, because then it's going to become 4x minus 2by is equal to 14. You see how that like looks more like the top? It's over there, so I am making it look more similar to that top version because they need to be the same exact line if there's infinitely many solutions. So now let's see, what could we do? So A is going to equal 4 because they have to be the same equation. So that's easy. And then negative 2b has to equal negative 7 if they're going to be the same equation. So negative 2b, because that's the number being multiplied by y, or what's being multiplied by y. And what's being multiplied by y on the other equation is negative 7. So those have to be equal if they're going to be the same line. So then I'm going to divide by negative 2. That gives me positive 7/2 for what b is. So now remember, I'm trying to find out what a over b is. So I'm going to do a divided by b. A is 4, and I'm dividing by, because the fraction bar is the same thing as a division symbol, dividing by what b is right here, 7/2. Remember, 4 is the same thing as 4 over 1. So when we're dividing with fractions, we have to KCF, keep, change, flip. So I'm going to keep the 4 over 1. I'm going to multiply, because I'm changing the division to a multiplication symbol, and then I have to flip 7/2 to be 2 over 7. So now, when I multiply across, I'm going to get 8/7, so the answer should be F. So let's go to number 6, and also, sorry if I'm missing any questions in the comments. There will be time at the end for any questions, just so you guys know. And if you're interested in getting my book, this is what it's called. It's available on Amazon. So let's keep going. Number 6. It says, in the system of equations above, b is a constant for which of the following values of b does the system have no solution? So no solution would be like we have the same equation but different different numbers that they're equal to, because then that's like not possible, no solution that they're going to ever like intersect. So let's see how we can make that work. So let me just look at these really quick. So hold on. I could say that hold on. If I divide this by 2, then it looks like y. Okay, so that's basically what I have to do. Just divide by 2. So then this, I'm dividing the bottom equation by 2, so then it's going to be b over 2 times x plus y is equal to 5. And then we have the same equation on top, the negative 4x plus y is equal to 8. So it's asking, like, when will we have no solution? Well, that's when we have, like, the same equation right over here equal to 2 different numbers, because then that means they're never going to, like, that's never going to work where they intersect. So we're going to have negative 4 equals b over 2. So then if we multiply each side by 2, we're going to get negative 8. So b would have to be negative 8. Okay, so let's go to number 7. It says, Mike's aquarium has 620 liters of water and can drain 13 liters per minute. Nancy's aquarium has 700 liters of water and can drain 17 liters per minute. Suppose both aquariums start draining at the same instant. After how many minutes will the aquariums have equal amounts of water? Okay, so let's do an equation for like Mike and Nancy. So for Mike, it'll be that y is equal to 600, yeah, it said 620 liters at 13 liters per minute is what it's draining. So like we're starting with 620 liters and then it's draining, so it's going down by 13 liters per minute. And then we would say that that's Mike. And then for the amount of water in Nancy's, what is it, an aquarium? Yeah. Nancy's aquarium, it would be y is equal to, she's starting with 700. And then it's being drained by 17 liters per minute, so minus 17x. So this is Nancy. And after how many minutes will the aquariums have equal amounts of water? Okay, so if this is like the amount of water for each of them, like that's Mike's and that's Nancy's amount of water, then we just set them equal to each other, the two equations, to find out when they have equal amounts of water. So it'd be 620 minus 13x is equal to 700 minus 17x. And then remember, x is like the minutes, so we would just be solving for x essentially. So we would just subtract 620 from each side, so then we get negative 13x is equal to 80 minus 17x. Then we need to add 17x to each side, so then we're going to get 4x is equal to 80. And then we're going to divide by 4 on each side, and we're going to get x is equal to 20. So it would be after 20 minutes. So then let's go to, someone asked if they could use this in real life. I guess they could use this in real life for like at the aquarium. I don't know what they do. So then let's go to number 8. It says that we have these systems of equations and then find the value of y over x, round your answer to the nearest hundredth. Okay, so let's write these on top of each other so that it's easier to see and work with. Okay, so I'm probably just going to do substitution for this one. So I'm going to get y by itself here. So I'm going to subtract 4, actually I'm going to do it down here so I don't run out of room. I'm going to work with this top equation and I'm basically going to get y by itself, so I'm going to subtract 4x from each side first. So if I subtract 4x from the top, I'm going to get 2y is equal to 18 minus 4x. And then I'm going to divide by 2 to get y completely by itself. So then I'm going to get y is equal to minus 2, or y is equal to 9 minus 2x. So now I know that y is the same thing as saying that. It's equal to that. So instead of saying y, I can say 9 minus 2x in my other equation. I can just put that in for y up here. So I can say 3x minus 5 times 9 minus 2x is equal to 15. And then I can say, okay, I have 3x, and then I'm going to distribute the negative 5 to each of my terms in parentheses. Negative 5 times 9 is negative 45. Negative 5 times negative 2x is positive 10x. And that equals 15. Now I just need to combine my like terms of 3x plus 10x, and that's going to be 13x. I copy over everything else. And then I'm going to add 45 to each side, so then I'm going to get 13x is equal to, and then that's going to be 60. So then I'm going to say, okay, now I'm going to divide each side by 13, and that's going to be 60. Oopsies. 60 over 13. Someone said slow down. AI, I'm not AI, but I'm doing this live, okay? So hold on. Give me a second. So now it's 60 over 13. What are we trying to find? We're just trying to find, y over x. So we have what x is. Now we have to plug it in to find y, and then we can do y over x. So let's see. Which of the equations do I think would be easier? I'm going to just do it with the top one right here. So I'm going to say that, oh wait, actually, the easiest way would be just to use this one right here. Way easier. So I'm going to say y is equal to, and then I'm going to say 9 minus 2 times 60 over 13, yeah, is what our x value is. So I'm just plugging that in for x, and then I'm solving to get what y is. So then I'm going to get y is equal to, and that's going to be 9, and then that's going to be minus 120 over 13. Now I have to say this is the same thing as 9 over 1. How do I make it have a common denominator of 13? Well, I'm going to multiply the top and the bottom by 13. So then when I do that, I get y is equal to, that would be 117 over 13 minus 120 over 13. And then I would just keep my like denominator of 13 and subtract the numerator, so I get negative 3 over 13 for y. Now remember, I want y over x, or y divided by x. So I'm going to do the y, negative 13, or negative 3 over 13, sorry, divided by the x, which is 60 over 13. When we're dividing with fractions, we keep change flips, so I'm going to keep negative 3 over 13. I'm going to change division to multiplication, and I'm going to flip this to be 13 over 60. These can cross cancel. You could also multiply across and then simplify after if you prefer, but this is faster. So these cross cancel, and then 3 goes into both negative 3 and 60, so it goes into negative 3, 1, negative, it becomes negative 1 when you do negative 3 divided by 3. And then we have, if we do 60 divided by 3, that's 20. So then it would be negative 1 over 20. So negative 1 over 20, that's going to be the same thing as, that would be the same thing as, because that's 5 over 100, yeah. So that would be b as a decimal. So let's keep going really quick. Hold on. I just need water really quick. Okay. So, let's go to number 9. It says, Jake's internet plan charges 10 cents per megabyte, is what that's what it's called. Megabyte for data used within his data cap, and 20 cents per megabyte for data used outside of his data cap. She's doing that. Teacher explain. We need the YouTube version. Okay, if you guys want a slower version, it's on my YouTube, which has the same name as this account. And then people asking what book it is. This is my book called Overcoming ACT Math by Sofia Garcia. It's available on Amazon. Okay, so it says, okay, so we're getting back to this. If he uses a total of 1,000 megabytes and his bill was $120, how many megabytes did he use outside of his data cap? Okay. Guys, be nice to each other in the comments. Okay, so his data plan charges 10 for data used within his data cap and 20 cents per megabyte for data used outside of his data cap. If the total of 100, okay. So let's say X is within his data cap, and Y is going to be the amount that he's using outside of his data cap. So if he's using a total of 1,000 megabytes, we would say X plus Y, the inside, his data cap and outside, is going to equal those 1,000 megabytes. Sorry, I keep saying milli. And then his bill was 120. So remember, it's 10 cents for the data used within, which we're representing by X, the amount of megabytes he uses, X, and it's 20 cents per every megabyte he uses outside of the data cap, which is represented by Y, and that has to equal 120. How many megabytes did he use outside of his data cap? So we're looking essentially for what Y is equal to. So, let's see, the easiest way to probably do this would just be to, well, first of all, I would just multiply all of this by 100, so I'm not working with decimals, because then I can move everything over by 2. So then I would say that this is 10x plus 20y is equal to 120, add 2 zeros, so 12,000. And then now I can say, okay, I'm going to solve for what I'm trying to find what y is. So I'm going to say that I'm going to solve for what x is in this equation so that I can solve for y in this one. So I'm going to subtract y from each side of that equation to get x by itself. So then I have 1,000 minus y is equal to x. So I can substitute that in for x right over here. So now I'm going to say I have 10 times 1,000 minus y plus 20y is equal to 12,000. And then we're going to say, okay, I'm going to multiply each of these terms inside the parentheses by the 10 outside. So this is going to be just 10,000 is what that turns into, minus 10y plus 20y is equal to 12,000. So then we have 10,000, and then this is going to be plus 10y is equal to 12,000. And then now I'm going to subtract 10,000 from each side to get y further by itself. So then that's going to give me 10y is equal to 2,000. And then I'm going to say, okay, I'm going to divide by 10 on each side. So then y is going to equal 200. So it should be g. Okay, so let's go now to number 10. So it says for number 10, we have these equations. In reference to the equation above, D and R represent the price per gallon in dollars of diesel and regular gas, respectively. So this is the diesel, this is the regular. X weeks after January 1st, what was the price per gallon of diesel when it was equal to the price per gallon of regular gas? Okay, so what was the price? We're basically trying to find out what D is when these equations are equal. So first we need to figure out at what x value are these equal to each other. So we need to set the equations equal to each other. Then once we have that x value, we can plug it in there to find what D is. So we're going to say 2.5 plus 0.20x is equal to 2.2 plus 0.30x. And again, well, that could just be the same as 0.3 and 0.2. I don't know why I wrote that extra 0. So I can do that same little trick again that I did up here where I'm going to multiply, but this time I'm going to do it by 10, multiply by 10 so that every decimal place moves over by 1, so I'm not working with decimals anymore. So then that would be 25 plus, and that's going to be 2x is equal to, and then this is going to be 22 plus 3x. Now I'm going to subtract 2x from each side, so then I'm going to get 25 is equal to 22 plus x. I'm going to subtract 22 from each side. That's going to give me 3 is equal to x. Now remember, x is the number of weeks. So x is 3, but I'm looking for what d is. That's what the problem asked me. So if I plug in 3 for my x up here, I can then figure out what d is. So 0.20 times 3, that's going to be 0.60. So 60 cents plus $2.50 is going to be $3.10, so it would be B. Okay, so let's keep going to the next portion, right over here. Whoops, wrong page. Okay. So now we have number 11. An arcade game accepts both tokens and quarters. The cost of a token is 50 cents and a quarter is worth 25 cents. Today the machine has collected a total of 350 tokens and quarters, and the total amount of money collected is 125. How many quarters were used? Okay, so we're basically trying to find the number of quarters that were used. So let's see. So let's call T, we'll use T for tokens and Q for quarters to make it easy. And we'll say like the number of tokens plus quarters have to be 350. And then the total amount of money collected was 125. And each of the tokens, the cost of each of the tokens is 50 cents. So it would be 0.5 times T plus, and this would be 25 cents for the quarter, so 0.25 times the number of quarters. So again, I'm going to multiply this, but this time I'm going to multiply it by 100 so that it moves over 2 decimal places and I don't have to work with pesky decimals. So then this is going to be 50t when I multiply by 100 plus 25q is equal to 125, and now I'm trying to solve for what q is. So I'm going to get t by itself up here. And I'm going to say, if I subtract q from each side, I get t by itself. So t should be equal to 350 minus q. What that's now going to allow me to do is substitute in this 350 minus q for the t value right here because they're equal. They're the same thing. So now I'm going to say I have 50 times 350 minus q plus 25q is equal to 125. Now I'm going to distribute the 50 to each of these terms in parentheses right over here. So I'm going to do 350 times 50. That's going to be 0, 0, 5, 2, and that's 17. Okay. So that's going to be 17500. And then we're going to say minus 50q. Oops, that's supposed to be a q. Plus 25q. Equals 125. So now I'm going to combine my like terms of minus 50q and plus 25q. And that's going to equal 125. So now I'm going to subtract 17,500 from each side. So then I'm going to have negative 25q left over here is equal to, and then that's going to be minus 17,375 over here. So then I'm going to divide by 25 on each, or negative 25 on each side, sorry, to get what q is equal to. So if I do 17,375, I mean technically this is the ACT, but I forgot where I put my calculator right now, so we're going to just do it by hand. We're going to say, okay, 25 goes into that. That's going to be 6 times. Yeah, 6 times, because it doesn't go to 175. So that would be 150 minus, and then we're going to get 23. And we're going to say 25 goes into that. That's going to be 9 times. And that's going to be 225. So then we subtract. We're going to get 125. 125. That's going to go in 5 times. 695. hold on. That's 695 for Q. Hold on. I think I did something wrong, because I don't remember that being the answer, because I've done this before. I had to have multiplied something wrong. Hold on. Oh, because I forgot to do times 10, times 100 times this. I was like, that is crazy. I've done this before, and it was never that. Wow, I'm a dum-dum. Okay, sorry, guys. So we're going to add 2 zeros there. 2 zeros there. So this is actually supposed to be negative 25Q, and then that's going to be minus 5,000, just minus 5,000. Okay, so then that would be Q is equal to 25 goes into 5,000. Well, that's easier to work with. So then that's just 200 times. So Q is equal to 200 H. Okay, so let's go to the next one. Number 12. A system of equations graphed above for y is equal to f of x and y is equal to g of x. What is the value of x for the solution to the system of equations graph represented by the graph? So remember, when you're graphing systems of equations, or like even when you're not graphing, you can like think of it like this, as like where they intersect is the solution to the system. So like the solution would be right here, because that's the point of intersection. Be careful with the scales also, because like sometimes they like to go by like 2's for each of the squares. Here you get lucky and it's just by 1. So that just happens to have an x value of 1. But just like in another problem, it might not have that. So that's why it's D. So let's go to number 13. So for number 13, it says if xy is the solution to the system of equations shown above, then what is the value of all of this? Okay, so we need to find out what x and y are and then basically plug that into here. So why don't we do the whole like multiplying by 10 thing? Or actually, yeah, only by 10, because you only need to move it over by 1 decimal place. And this time I won't forget to do the whole thing by 10. So we're going to multiply this by 10 as well, because it just needs to move over by 1. So then we're going to have 5x plus 4y is equal to 7. And then this would be 3x plus 2y is equal to, and that's going to be 4. So, I mean, you could do, I'm going to do elimination since I haven't done elimination in a couple problems. So I'm going to say that this, I'm going to multiply by 2 because I'm trying to make it look like the 4y so I can easily like subtract and eliminate the y's. So I'm going to multiply by 2 and keep the top the same. So then it's going to be 6x plus, that's 4y is equal to 8. This is supposed to be a 4. Okay, so now I'm going to subtract because that's going to let me eliminate these y's right there. And then I'm going to get negative x is equal to negative 1. So then if I just divide by negative 1 on each side, I'm going to get x is equal to positive 1. So I know what x is. Now I have to plug it into one of these equations to find out what y is. So I'll just pick the top one, the 5x plus 4y one, equals 7. And I'm going to say, okay, instead of x, I know x is 1, so I'm going to just plug in 1 for that. Plus 4y is equal to 7. So I'm going to have 5 plus 4y is equal to 7. If I subtract 5 on each side, I get 4y is equal to 2. And then now I'm going to say, okay, I'm going to divide by 4 on each side. So I get y is equal to 1/2 because it's just 2/4, which is just the same thing as 1/2. So I know x is 1. I know y is 1/2. So now I'm going to plug it into here to find out what 4 over y minus x is. So 4 divided by y, so 4 over 1/2, because that's what y is, minus what x is, which is minus 1. Well, 4 divided by 1/2, that's just 8. So then that would be 8 minus 1, which equals 7. So the answer should be 7 for this one. And then let's go to the next one right here. How many solutions are there for the systems of equations shown above? So here we have, they look pretty similar. Are you sure? Someone said that they think this is wrong. I mean, I'll double check the key. Hold on. And get it out really quick. What is that? Number 13? Number 13 should be 7. So check your math again. Okay, so then number 14, how many solutions are there for the system of equations shown above? So here's the system of equations right here, And remember how I said like a little while ago, like you want to make them look as similar as possible for like the no solutions or the infinitely many solutions thing. So like for this one, they already kind of look pretty much the same. They're saying that 6x plus 3 has to give you y, and 6x plus 5 has to give you y. Remember, if these were to be like a systems of equations, they would have to have a point of intersection. They would have to intersect. So it would have to, at some point, 6x plus 3 would have to equal 6x plus 5, which is impossible. That's never going to happen. So there would be 0 solutions to that system. Let me get water really quick again. Oh, and hold on 1 second. Okay. Okay, so number 15 says, how many XY solutions are there for the system of equations shown above? So here again, whenever they're talking about how many solutions, you want to try to like do the thing where you try to make them look the same, because that's going to be either the no solutions or the infinitely many solutions. So that's always like my first step. So like here, I'm going to say, okay, probably with the fraction one, what can I multiply that by to get to the second equation right over here? So if I multiply by 12, that I think would work, because yeah, that would be 60 over 6, which is 10. 12 times that would be 3, so then yeah, we're getting something similar. And then 12 times that would be minus 2. Yeah, so I'm going to multiply this by 12, and then that's going to give me 12 times 5 is 60, so 60 divided by 6 is 10, equals 1/4 times 12 is going to be 3x, and then 1/6 times 12 is going to be negative 2y. So now I have this equation, which looks very similar to this one, but it's a little bit different. But I can fix that and make it look identical by just subtracting 3x from each side. So I'm going to say 10 minus 3x must equal negative 2y. I have the same exact equation on top and bottom. So if I have the same exact equation and I were to graph them, they would be like right on top of each other. They're the same equation, the same line. They have infinitely many solutions. So this one would actually be that it's k, none of the above, because it's infinitely many. Are you guys getting a black screen, someone said? Hopefully not. Okay, let's keep going. So number 16 says, how many real solutions are there for the function f shown above? Okay, good. People aren't getting a black screen. That's good. So people are saying, I don't get it. So when you're doing a systems of equations, like here, for instance, it's easier to see with a graph. Like here, there's one point of intersection. So there's one solution. Now, if g of x was like right on top of f of x, like if there were the same exact line, like you had g of x and f of x right there, they're intersecting here, 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 like everywhere on each of their lines. So there's infinitely many points of intersection. There's infinitely many points that work for both, infinitely many solutions. So by seeing how these are the same exact line, I say, okay, well, if they're the same exact line, if I were to graph them, they would be right on top of each other. So that's infinitely many solutions, because they're going to intersect everywhere. So now let's go to number 16. It says, how many real solutions are there for the function f shown above? So this is our function f shown above. So whenever they're asking about number of solutions with quadratics, meaning like the highest degree is this 2 right here, you're going to think b squared minus 4ac. That's the determinant formula, equation, whatever you want to call it. So a, b, and c are determined by what's being multiplied by each of these terms, and then also what's floating by itself. So a is going to be the number that's multiplied by whatever's being squared. B is going to be the number multiplied by the x, and c is the number floating on by itself. So if we plug that in here, we're going to say b squared is going to be root 3 squared minus 4 times a is 2, and then c is 8. Root 3 squared is going to be 3, and then minus, this is going to be 8 times 8, which is going to be 64. So that's going to be negative 61. Now, it doesn't really matter what number this is exactly. It just matters like if it's negative, positive, or equal to 0 for this part. So whenever we have a negative value, meaning like this ends up being less than 0, that means that there's 0 real solutions. This is a negative value, so there's 0 solutions. So let's go to number 17. For number 17, it says, for which of the following values of k does the system of equations intersect at exactly 2 points? Assume k is a constant. Okay, so we're going to remember if they're intersecting, they're equal to each other, they have the same x and y at that point, so we can set the equations equal to each other, and we could say x squared plus kx has to equal negative 2. And then you see how this has the highest degree is like a 2, it's a squared term. So this is a quadratic. Remember what I said with number of solutions, when they're talking about number of solutions with quadratics, think of this guy right here, the b squared minus 4ac. But the trick there is you can only use that once this is, once you set this equal to 0 in this case. So we have to say that x squared plus kx plus 2 has to equal 0. So I had to add 2 to each side to get the quadratic equal to 0 before I can use this. And then it's the same rules apply for how to determine what a, b, and c are. So a is the number being multiplied by x squared, so that's just 1. B is going to be equal to k, because that's the number being multiplied by x. And c is going to be the number floating by itself, so that's going to be 2. Now, it's saying that it intersects at exactly 2 points. Another way of saying that is there's exactly 2 solutions to this, this quadratic. So just like there was a rule for when this is negative, there's a rule also for when it's positive. When this is greater than 0, there's 2 real solutions. So essentially what we want to do is plug in what a, b, and c are into this and make sure that it's greater than 0. So that's what I'm going to do. I'm going to say b squared, k squared, minus 4 times 1 times 2 has to be greater than 0. So it's going to be k squared, and then that's going to be minus 8 has to be greater than 0. So then I'm going to add 8 to each side. So then I'm going to get, I'm sorry, k squared is greater than 8. And then basically like we're being asked for what k is, right? Yeah, what k is. So which of these squared would be greater than 8? Well, definitely 3 squared is going to be greater than 8, because that's going to be 9, which is greater than 8. So it would be G. Let me get water really quick, guys. Okay, so did you forget to add on both sides for 16? There's no 16, that's 4 times 1 times 2, which is minus 8. So it's plus 8 to each side. So, hold on. Hold on, I'm trying to answer questions. Let's see. Someone said, so you don't, it be none of k, it's just constant. No, because 3 works, because 3 squared, k would be 3. 3 squared is greater than 8, so that works. Okay, so let's keep going to number 18. So for number 18, it says how many solutions does the following equation have? So let's start by distributing this x to each of these terms. So it would be x squared minus 3x is equal to, now I have 2 terms plus or minus in parentheses times 2 terms plus or minus in parentheses. So that indicates I have to FOIL. FOIL is an acronym that stands for what I need to multiply together. So the F stands for first. So I need to multiply the first things together, x and x, to get x squared. O stands for outer, so I have to multiply the outer stuff, so x times 1. I stands for inner, so I have to multiply negative 2 times x, so that's negative 2x. And then L stands for last, so I have to multiply negative 2 times positive 1. So that's negative 2. Now I'm going to combine my like terms here of x minus 2x. So that's going to give me x squared minus x minus 2. And on this side, I'm going to get x squared minus 3x. Now, what I could do is, honestly, like this is probably just like solving for x is the easiest route to go. So if I subtract x squared from each side, it's going to cancel out. So then I have negative 3x is equal to minus x minus 2. And then I'm going to add x to each side, so then it's going to be negative 2x is equal to negative 2, and I'm going to see that I have only one solution. So then this is just going to be b, because x is only going to equal one thing. It ends up equaling 1 also, but it's only one solution. I only got one x. I wasn't getting like x is equal to 1 and 3. There's only one solution. So now we're going to, what are the solutions for the following equation? For the solutions to the following equation, this and this. Okay, so let's get this y by itself just like it is over here. So then that would be x squared minus 3x is equal to y. Oh, and that's just the same one as up here. Yeah, I remember writing this problem. Okay, so if you see that, you'll see we have the same exact thing up here. So we already solved for what x is. So we could say x is equal to 1, because when we set these equations equal to each other, we're going to get, this is supposed to be a y. When we set the y's equal to each other, the equations equal to each other, we get that x is equal to 1, which we already did. And then we're going to plug that into either one of these equations to solve for y. I'm going to just pick this one right here. So I'm going to say y is equal to, if I plug in 1 for x, I'm going to get negative 1 times positive 2, which equals negative 2. So it should be 1 comma negative 2. So it would be f. So now let's go to number 20. What values of b would cause the following systems of equations to have no real solutions? So remember, no real solutions, if we're talking about systems of equations, means like they never intersect, and it's never going to work out, basically, where they are like meeting each other on the graph. So let's say, okay, if we set these equations equal to each other, it should be impossible for it to intersect, basically, if we have no real solutions. So now what I'm going to do is, I see a quadratic, so I'm going to try to get this all equal to 0 by moving the minus 3x and the plus k to this side. Thank you for the pizza. So I'm going to add 3x to each side and subtract k from each side. So then it's going to be 2x squared plus 3x plus 4, and then I'm going to say plus 3x minus k makes it equal to 0. So now I have 2x squared plus, if I combine these like terms here, 6x, and then plus 4 minus k is equal to 0. Now remember, with a quadratic, if you want it to have no real solutions, the discriminant, b squared minus 4ac, has to be negative. So it has to be less than 0. So here, my a is going to be 2, my b is going to be 6, and my c is the rest of it over here, 4 minus k. So I'm going to plug that into the discriminant formula, and I'm going to say, okay, 6 squared minus 4 times a, which is 2, times c is going to be 4 minus k. That has to be less than 0. So then it's going to be 36 minus, and this is going to be 8 times 4 minus k is less than 0. So 36 minus 32 plus 8k is less than 0, because I distributed that negative 8 to each term in the parentheses here. And then I'm going to say 36 minus 32, that's going to be 4. So 4 plus 8k is less than 0. So then I'm going to say, okay, well, actually, let me just move the 4. So I'm going to say I'm going to subtract 4 from each side. So I'm going to get 8k is less than negative 4. Then I'm going to divide by 8 to get k completely by itself. So I'm going to have k is less than negative 4/8. And if I divide by 4, the greatest common factor on top and bottom, I get k is less than negative 1/2. So k is less than negative 1/2. That would be b. And give me 1 second to get water again. Okay, so let's go to the next one. 21. Find the vertices of the solution set of the solution region for the following set of inequalities. Oh yeah, I remember this one. Hold on. This one, what you're gonna do is, hold on, let me set it up to the side really quick. Now, usually these look a little bit different, but basically what you do is you plug this into your graphing calculator. I'm going to put this on Desmos just so you guys can see like how it looks graphed, and it shows like the different colors so it's easier to see. That's greater than. And zoom out. There we go. Okay, so basically what I did is put this into the graphing calculator. And you get a graphing calculator on the ACT, yeah. That's why I'm saying like that's what you do on the test. So like you put it all in there, and then basically like the solution region, sometimes they call it, what's the other word? Feasible region. They're asking you for the vertices, so it's like you're checking where like the shading would go for all of them, where does it overlap. So it would basically be like this portion right here is where it all overlaps. So the vertices would be like this guy and this guy are vertices right there. So 2, 4 and -2, 8. And then, so that would just be, that's F. So, oh yeah, you could also plug in, if you want to, like, kind of do it that way, but, I mean, it's faster to just do, like, the, the graphing calculator. So, let's go to number 22. It says that we have these right here. For the system of inequalities above, assume C and D are constants. If 2, 25 is a solution to the system, and D minus C must be a prime number less than 19, then what is the value of D minus C? So we want to know D minus C. Okay, so we have these guys right here, and then it says that this is a solution, so this is an X and a Y, because it's a point X, Y, and it's a solution to this. So I can plug in 2 for X and 25 for Y there, because they told me it's one of the solutions. So I'm going to say 25 is greater than 10 times 2 plus C. Same thing over here. I'm just plugging in the solution, x, y, over here. And then I'm going to say, okay, that's 25 is greater than 20 plus C. So then if I subtract 20 from each side, I'm going to get 5 is greater than C. I'm going to do the same thing over here. So then it's 25 is less than 6 plus D. So then that's going to be that if I subtract 6 on each side, 19 is less than D. So I want to know what D minus C could be. So probably what I tried doing is just like guessing and checking based off of like C has to be a number less than 5 and D has to be a number that's greater than D, and then D minus C has to be a prime number that's less than 19. So there's not going to be that many options. So I would just start plugging in for these. So like let's say C is equal to 4 because that's less than 5. And D is equal to 21 because that's greater than 19. So it follows the rules. Then D minus C would have to be 21 minus 4, which equals, that would be, what is that? Is that 21 minus 4? Yeah, that works. That's 17. Okay, so that works. That one works, yeah. But, hold on, let's try one that doesn't work so you can see like what something that didn't work would be. So let's see, I think 4 and 20 wouldn't work. So 4 and 20, because 4 is a number that's less than 5 for C, and D is a number that's greater than 19 for D. So if you wanted something that didn't work, 20 minus 4 would equal 16. That's not a prime number less than 19. So that's an example of like, oh, I know that this couldn't work, so that couldn't be the answer for D minus C. This does work. This follows all the rules of C has to be less than 5. C is 4. D has to be greater than 19, D is 21, and if we subtract them, we get 17. So it's kind of like a guess and check sort of thing. So then that would be D. So then let's go to number 23. So for number 23, it says, which of the following satisfies the system of inequalities below? Right over here. So let's do like what someone said about how you would plug in to find the answer to show you that. But like this one, you could do like this one as well, where like you plug it into the graphing calculator and that would be faster. But just so you can see like another method, like maybe your calculator dies that day or something, who knows. So let's see. first of all, I would say like x has to be less than 3. So I can automatically cross out j because that's not having an x less than 3. Y has to be greater than 1. So I can cross out f and g because these are not values that are greater than 1. And I can cross out what k is because that's not a value greater than 1. So it would have to be h. And you could plug it into the last equation, the x plus y one, just to make sure. And you could say 1 plus 3, is that greater than negative 2? 4 is greater than negative 2. That works. So yes, it definitely should be h. So let's go to number 24. So number 24, for which of the following systems of inequality, or sorry, which of the following systems of inequalities matches the graph shown below? Okay. So we already see, the first thing I would check for is like, do we have one of them that uses both of the line ones? Like if this had a line underneath, I know I could eliminate that because I need one of them to be dotted, one of them to be solid. The ones that are solid are the ones with the little line underneath here. The ones that are dotted are the ones without it, but that's unfortunately not something we can use right here. So what my next step would probably be is to just like graph one of these lines and see like where the shading is to eliminate more answer choices then. So I'm going to start with the 3x minus y because I see a lot of them look like that, 3x minus y, and has 1 on the other side. So what I like to say with these is, I'm going to try the first one, like where it's greater than 1, is get the y by itself, and kind of treat it like a regular y equals mx plus b equation. So like what I'm going to do is I'm going to subtract 3, actually it's probably easier if I add y to each side and then subtract the 1, so that's what I'm going to do. If I add y to each side, I'm going to get 3x is greater than 1 plus y, and then I'm going to subtract 1 from each side to get y by itself. So then I'm going to get 3x minus 1 is greater than y. I like to write it with that on the left, so I just rewrite it like this. Y is less than 3x minus 1. You don't have to do that if you don't want to. I just think it's easier to like visualize that way. So now what I do is I pretend like this is y equals mx plus b, y is equal to 3x plus 1, to graph the line portion that has to be dotted. So it has to be like this dotted line because there's no line underneath the inequality symbol. And I'm going to say, okay, does this match with y is equal to 3x minus 1? So the y-intercept would have to be negative 1. And then we would have to have a positive slope. So that matches right there with 3x minus 1. Now let's talk about the shading, because that's where the inequality part comes into play. Sorry, the comments are funny. So then this is where the inequality is like important with the shading. So y has to be less than this line. So that means it should be shaded over here if it's less than. So it can't be A. Now, with this one, it's the same exact, like with B, C, and D, we see that there's the exact same equation for C right here. They all look pretty similar, but that's exactly the same, so it can't be C either. So now let's try it with 3x minus y is less than 1. You could also graph this in your calculator. I'm just showing you like the actual like logic behind it. So we would do the same exact thing, get y by itself, except this time the whole thing is going to be less than 1. So we're going to say 3x is less than 1 plus y. And then we're going to say 3x minus 1 has to be less than y. Again, I like to write it with the y on the left, so that's why I'm doing this, but you don't have to. So now y has to be greater than all of that. It's the same line that we graphed, 3x minus 1, but y would have to be greater, so the shading would have to be above. So that works out. So that part's correct. And now I'm going to see, okay, now I'm going to look at the second portion, the second inequality, sorry. And I'm going to see, okay, should it be less than or equal to 6 or greater than or equal to 6? So I'm going to do the first one where it's less than 2x plus 3y is less than or equal to 6. And then I'm going to say, okay, so now I'm going to get y by itself again. So I'm going to have 3y. Hold on, let me get rid of somebody. Okay. So I'm going to say 3y is less than or equal to 6 minus 2x. So then I'm going to divide by 3 on each side, so that's going to be 2 minus 2/3 x right here. So Here, I'm going to pretend that this is like my y equals mx plus b. So 2 would have to be, for the solid line, 2 has to be the y-intercept that's plausible, and it has to have a negative slope. So that works for that one. And then you'll see with D, 2x plus 3y is greater than or equal to 6. Let's see if that's going to work as well. So then let's see, that would be 3y is greater than or equal to 6 minus 2x. Y is greater than or equal to 2 minus 2/3 x. So then that would be the same exact line, and it matches that same exact line. Now let's talk about the shading. So y has to be less than or equal to the line for the answer choice B. So that means they would have to shade below the line for answer choice B. So if we look up here, that's not what they're doing. They're not shading below that solid line, so it can't be that one. But for D, if we look at what D says, it says that they're shading above because y is greater than or equal to. So they have to be shading above that solid line, which they do, that works. So it would have to be D right there. You could also check like this one doesn't work, like when you start doing it out. But yeah, if you wanted to do that too, but you already figured out those two work. So then let's go to number 25. And again, there's like way easier ways to do that. I was just showing you like the logical long version of like why that all makes sense. But you could literally just like plug this into your calculator, see what matches the picture if you wanted to. So let's see. Number 25, which of the following systems of inequalities matches the graph shown below? So, let's see, system of inequalities matching this graph. So, what would be the easiest way to go about this based off of the answer choices? Probably with like the vertex stuff. So let's see where the vertex is, or vertices, I don't know. We're gonna, where each vertex is, that's how we'll say it. So right there and right there is the vertex of each of those parabolas. So that would be at negative, it's going by 2. So -2 is the x value there for that vertex. And then the x value here looks like it would be at 1, just +1, because it's going by 2 and it's halfway. And then the same thing, it's going up by 2 over here. So that would be the +1, and that would have to be just 0 for your y right there. So these are the these are the vertex for each of these parabolas right there. So we have to keep that in mind when we're looking at the answer choices and how they're all set up with their equations. So that would have to mean that it's either going to be, it could be this one because that's -2, 1, -2, 1 for the vertex, because it's written in vertex form, where like the h is going to be like whatever the opposite of what's here is, and the k is whatever's being like added or subtracted to the whole thing. So that means that the h has to be -2, the vertex has to be -2. So that matches, that matches. It does not match h or j though. And let's see, for the other one, the vertex is 1, 0. So that matches too, because like it has to be the opposite of whatever is right here. And then like there's nothing added on, so that's like the k for 0. So now what you would probably do on the test, if you didn't want to like think much about this, is you could just like plug in each of these and see like what gives you that exact like this exact image in your graphing calculator to see like which one is it supposed to be. But what we can do instead is we can say where's the shading happening to see like which one's correct. So we could say y is less than or equal to the whole parabola right here is what it's saying. So that means it should be shading underneath it, which it's not, shading above. This one says y is greater than or equal to all of that, so it is shading above, so that matches. This one says the same thing where it has to be shaded above, so that matches, so it would be G.